Hi everyone, Sertal here. So in the last video we talked about how to solve a simple goalkeeper selection problem using OpenSolver on Microsoft Excel. In this video we will try to solve a single period full FPL problem with all the constraints that FPL throws at us using FPL review data again. So as I mentioned in the last video, you can use any resources you want for the expected projections for the points. So in this problem, we will be focusing on how to put those constraints that FPL gives us, like you can only have at most 3 players from every single team. Also, how many defenders, midfields, forwards you can have. You need to choose a captain, for example. So we will see how these comes into play. So in the last video I showed you how to download the FPL review data and install OpenSolver so you can start modeling. And in this video I will just download the data by fast forwarding my screen, and you will see how I am also importing it to my Excel. So I will go to FPL review. Okay, so we have downloaded the data, put everything here. I will also go ahead and just sort these values from largest to smallest so that we will be able to see what are the best selections for this week. So I'm solving this game week 23 problem, and we are assuming that you are using wildcard or free hit, so we are allowed to choose whichever player we want. So hopefully in the next video we will be also talking about how to use your current team squad and how to incorporate transfers. But in this video we will keep things simple, and we will try to choose 11 players for our lineup and 4 players for our bench while maximizing our points. So I will just center everything and also adjust sizes. Before I start, let me add a new column here called post numeric. So this will be the numeric value. So I will just use a switch method, and I will say use B2, and if it is goalkeeper it means it's type 1. If it is defender, type 2, M3, and forward 4. Okay, so I have these values, just let me copy it. Okay, we are good. Now we will start again by defining our variables. So what are we choosing here? What are our decisions here? And the first one is obviously lineup, whether I am going to have a player in my starting 11 or not. And I will just say everyone is at 0 currently. And similarly for my bench. In the goalkeeper problem, you could remember that we were only choosing a lineup goalkeeper and a bench goalkeeper, but in this problem obviously we will just change things a little bit. And also I mentioned that we will be choosing a captain, so the captain will be based on expected points, and it will be the player with the highest points, but we will let optimization choose the captain for us. So this will be also useful when you would like to include a vice captain with a certain weight into your decision making. And as I did in the previous video, I will just color these columns green, because these will be my decisions. These are my variables, what we call in optimization, and these points are my parameters. So these values are dictating what the optimal will be. And I will be using the by value, and I will be using the team names shortly, you will see, and I will be using also the position, and anything else at this point is not being used. So I'm only choosing lineup, bench, and captain, and anything else will be either a metric, so that I will be using inside certain FPL constraints, or they will be my performance indicator, my objective. So let's start with some of these metrics. The first one is squad. So you might think the squad is a variable, because obviously we are choosing our players for our squad, but you could think squad as outcome of whether you have a player on your bench or in your lineup. So if I have Son in my lineup, and then obviously I need to have in my squad, right? So this will simplify things a little bit, and also the number of variables in optimization is an important concept. So by keeping variables to a minimum, you can make the process go faster. And finally, points is my important thing here. So before writing points, let me define a new parameter called bench weight, and bench weight will be obviously a parameter. So this is how much you think your bench should be affecting your decision. We covered this in the previous video, but currently I'm setting this to 10%. You can obviously change this. Obviously with the COVID, people were talking about maybe having a strong bench is more important than ever. So based on your belief, you can change this weight, and I made this a parameter, so it will be easier for us to control this later. And my points is obviously I'm gonna multiply my lineup value with the points. Obviously, if the player is playing in my lineup, if it is in the starting 11, I need to get the full points, right? Plus, this is where the weight comes into play. I will multiply weight with my bench times points. So whatever the weight is, if that player is in my bench, it will be multiplied with the points. And finally, if a player is your captain, right, you need to get the full points, so you get another extra, so it will be doubled. So my points are a performance metric that I will be using. The next thing I need to do is defining the positions and their limits. So let me just scale this so I will have some more space here. So I will call this positions and squad. So I will start with goalkeeper, defender, midfielder, and forward here, and these are my squad limits. So these are the problem parameters. So this is what FPL requires. Obviously, we need to have exactly 2 goalkeepers, 5 defenders, 5 midfielders, and 3 forwards. And this column here will show how many of this type of player I have. So for this, I'm gonna use a function called SumProduct. SumProduct, essentially, whatever array we are gonna give, it will multiply it with another one. So the one thing here is we need to multiply whether a player is a goalkeeper or a defender or a midfielder. So we can put a condition by adding 2 dashes, and I will write the array here. So my array in this case is my position array. It goes from B2 to B646 is the last player. If it is equal to this position, so when you write it this way, this either gets value 0 or 1 based on whether it is equal to this goalkeeper, I mean the letter G. So I will multiply this with my squad here. So it will be L2 to L646. Okay, so just to test this, let's find a goalkeeper Mendy here, and I will add Mendy to my lineup. And as you see, this is already 1, another goalkeeper. Suppose Sanchez in my bench. And as you see, I have 2 goalkeepers already. So just to extend this formula, I will just put $signs here, because while I'm copying, I don't want this arrays to change except the position letter. So I will just copy these just to verify, double click on it, and as you see, I'm multiplying squad with this array, and this array being filtered using whether it's a forward or not. Again, let's test it. Let's have Son in the lineup and maybe Werner in my bench. So this is working. As I mentioned, this is a parameter, and these are the metrics that we are gonna use. And finally, we have limits for lineup. So lineup lower and lineup upper bound. So for each type, we know that we need to have at least 1 goalkeeper in the lineup, at least 3 defenders, 2 midfielders, and 1 forward. Coming from the rules, upper bound is you can only have 1 goalkeeper, 5 defender, 5 midfielder, 3 forwards. And this is my pick lineup. So this will show how many players I have, and in this case, let me actually move here. Can just copy this formula here, and as you see, it's currently multiplying position with the squad. But instead of squad, I will just move to the lineup, and it will be. And also, this should be equal to the goalkeeper, obviously. And as you see. So these are my metrics, these are my parameters, and as you see, it says I have a goalkeeper, which is correct in my lineup, and a midfielder, Son in this case, and the others are just in my bench. So we have the position, so we will be using this in our constraints. At this point, I will also put team names into a list here so that we will see how many players we are choosing from each team. So for this purpose, I will just choose all these team names. I will click data, and then I will click advanced filter. And as you see, I have options, and I will choose copy to another location. I have already done it before, so I will just choose this cell, and then it will be copying these values, but I will also say unique records only. So I will get the team list teams, and I get the teams, and I will be sorting them. Yeah, very good. So from each team here, we are allowed to have only we are allowed to have at most 3 players, right? So I will be defining a new column so that we can see how many players we have chosen so far. Again, I will apply the same trick. I will say from F2. Let me put dollar signs while I'm writing this so that it will be easier for me, and to F646 times. So these are the team names, and obviously I'm wondering if I have that player or not, so it will be L2 to L646, and we got an error. Let's see. I forgot the condition. So whether this value is equal to Q8 or not. Okay, so let me copy this, and as you see, it shows I have 2 Chelsea players. Let's see if that's correct or not. I have Mendy here, and I have. Let's see, I have Werner here. Yes, that's correct. I have 21. Okay, let's fix this by moving everyone here. Okay, so this is obviously a metric that we will be using. Okay, so besides these, we need to have a count on how many players on our lineup, and bench count. So again, this will be this is easier because this will be only the sum of all the I values here, and similarly for the bench, as you see, it's the sum of all the bench players. And we know the limits. For this one, we need to have 11 and 4 bench players exactly. And again, these are blue, limits are parameters. We'll be just adding a new column here. And at this point, we need to add just 2 more elements here. The first one is our budget constraint. So for this purpose, I will have a value called cost. I think we forgot something. Yep. I forgot to add dollar signs here while I'm writing the function. Okay, now it's fixed. I will have my cost here. This will be the sum product of whether I have a player in my squad times the buy value. So it will be D2 to D646. So this is currently the cost. So I will also put a budget. I will say maybe 100, is my limit currently, so this will be metric. My budget is a parameter, and after this I also need to have a captain sum. So I will just put captain question mark. So this will be the sum of K2 to K646, so that I can make sure that I'm choosing a captain, exactly a single captain, not two captains. Not I won't have a team without a captain, so this will be exactly equal to 1. And finally, so we are ready to model the problem, except we don't have a metric. Like, what are we trying to maximize here? So I will measure my total points by taking simply the sum of all these values at the M column. So currently my total points is 12. So, but remember, this includes my bench players and my captain. So if I put 1 here, as you see, the value will be multiplied by 2. And also from my bench players, I'm getting only 10%. So this total points is your measure of how good your team is based on maybe the expected points. So since this is our objective, so this is the thing we are trying to maximize, I will just color it with a different color so that we will understand what's the objective in this sheet. And I think we are now ready. We have everything we need. So I will come here and click model, and the first thing, of course, we need to do is choosing the objective. What are we trying to do? We are trying to maximize this exact cell. Okay, awesome. So the second thing is variable cells, is your decisions. Again, this will go from I2 to K646. When I write it, if I save it, you will see that it's already highlighting all these variables until the end. So I will click model and model again. So we have our objective and our decisions here. Now we need to add our constraints. So the first thing we will add is we need to say that these values here can only take values 0 or 1, not any other value. So I will put their name here, and then I will say binary, so that optimization will force them to be 0 or 1. So another constraint we need to have is our captain, as I mentioned. So we need to be sure that this is exactly equal to 1. And the next constraint is our budget. Obviously, the cost should be less than or equal to my budget always. And let's see, the next one is my these squad values, like how many players of each type I own in my squad, should be equal to FPL limits. Left hand side constraints must be a range. It is a range, but let me remove this. Yeah, okay, it worked. I will just save the model, and then you will see that there's already an indicator for the constraint. So we verified that the constraint is correct. So I will do the same. I will choose my lineup, and I will say setting S for some reason, but anyway. So these should be greater than or equal to their lower bounds here. Not sure why it's adding S, but yes. So you see, it's already highlighting these two. And also I will do this again for my upper bounds. So I will say these. I will just type it at this point. So this will be W2 to W should be less than or equal to V2 to V5. And let's add the constraint, click on it. Yep, looks correct. And when I click save, you see that all the constraints are visible now. I will click model once more, and I will be saying all these values here without the extra S should be less than or equal to 3. So we are saying these values, so you are allowed to choose only 3 players from every single team here. And finally we need to have we need to add this. So we need to say these 2 value here should be equal to these two values here. Exactly. And let's see, do I have anything else? Oh yeah. So one thing here is optimization doesn't have any idea that a captain should be picked out of our lineup. So it is possible that the captain, I mean, it probably won't happen because we will probably choose the player with the highest expected points into our lineup, but that might not be the case if the player is too expensive. After all, we are solving a knapsack problem. So we need to say optimization that my captain here, all these values all the way to the bottom, is less than or equal to, let's see, less than or equal to my lineup values here. So if my lineup value is 0, I'm saying that there is no way for this player to be the captain, so it should be out of lineup. And when I click OK, say model, you will see that everything is just everything is being highlighted. You can hide the model this way, and I will go ahead and just make everything 0, so we can start from the 0 solution. So we have everything ready. Let's click solve and solve again, and as you see, it's running. Okay, we have our solution. One thing we have forgotten here is when a player is being chosen, so there's a chance that, I mean, obviously optimization doesn't know that we can choose the same player for both lineup and bench. I mean, this is something that we shouldn't allow. So the squad values should be less than or equal to 1, which I will add very quickly. I will say, I will just type it, it will be faster hopefully. K2 to K646, all these values should be less than or equal to 1. Same model. Oops, I made a mistake. It's not the K, it's the L. Same model, okay. Again, I will just hide this. I will click solve, and then the solver is solving, and then we get our values. I will click here sort, and I will sort this by lineup. First of all, largest to smallest, and then bench, largest to smallest among the same number. I will just sort by position number, so that I will see the goalkeeper at top. And finally points largest to smallest, and as you see, we finally have our solution. Mendy is our keeper. We have 3 defenders, 4 midfields, and 3 forwards, and we also have our bench here. So at this point, I mean, we have already solved the problem. You can go ahead and try different things, like maybe you don't want to have, let's say, 2 Manchester United players in your team. I mean, so this is a valid solution, but maybe you want to have only at most single United players, so, or maybe 0. So you can click here. You can add this constraint as this specific value should be less than or equal to whatever limit I am writing here. I will add this constraint. I will save the model. I will click solve again, and you will see that it will choose a squad without with only a single United player, and this is my again the solution. This is my lineup, and as you see, we have a single captain, Son in this case, and we have our bench, and from United we only have Bruno, and we solved the problem. This is basically the maximum points you can get. But notice that when it was unlimited, I mean when it was only 3, if you could, when you solve this problem, instead of 61.9, it was 62.7. So this is what we call a suboptimal solution, because when you think about it, optimization is trying to find you the absolute best solution you can have out of these options, right? So by forcing it a certain direction, by limiting how many players you can have from a single team, or maybe by forcing a formation, which I will try in a second, you are limiting your options to a smaller set, and among these, optimization is returning you the best solution. But remember, this best solution, the optimal solution for the smaller problem, is still inferior compared to the original problem's optimal. So this is what we call a suboptimal solution.
So in this case, for example, I can say maybe I don't want 343, I want 442. I'm very stubborn about it. I can click model, and then I will say, you know what, these defender, midfield, and forward values in my lineup, they should be less than, sorry, not less than or equal to, but should be exactly whatever I want. I mean, this is the value I want. I will add constraint, save the model, and resolve the problem, and then you will see that this value will change. So the value changes, but not very significantly. So you might be thinking, yeah, but like, what's the difference between 62.7 and in this case it's 62.0? You're right. I mean, so we have lots of suboptimal solutions in FPL. So optimal is not like a solution that is far from others. But by enforcing these kind of like custom constraints, you can change your budget based on whatever money you have in your budget, or maybe you can even force a certain player. I mean, you can say that this game week, I believe a certain player, let's say. I don't know, maybe Salah. I need to have him in my lineup. So you can create a new constraint. You can say that, yeah, I will have Salah regardless whether he's not like his expected points are good or not. And then you are limiting your options, but you will see that these total points are not changing significantly in most cases. At this point, I also should mention that in OpenSolver, we were using CBC solver. If you click solver engine under this menu, you will see that we were using CoinOR CBC. It is the default solver. It's an open source mixed integer linear optimization solver, and you can use different solvers. OpenSolver is giving you some availability on it. One thing I need to mention is NAOS, network enabled optimization system. Think this like a cloud instance, a cloud system where you can submit these problems to cloud and then you get the solution back. Due to network, this could be a little bit slower. The solving the problem is almost always the same, but there's a queue system in here, so you might need to wait a little bit. But this is a good option if you don't want to like keep this or use your own computer for solving these problems. One thing to mention is it is publicly available, so meaning that whatever problem you are solving, other people can see that. Our OpenSolver installation came with a linear solver already, so you can use it simply. You can use your own machine resources. Another thing to mention is under model, if you click options, you will see a bunch of options here. You can just try to read what these are. One thing to mention is branch and bound tolerance. Currently it says 5%. So the branch and bound is what we are using as an algorithm to solve these problems to optimality. So this is the standard for using mixed integer linear optimization problems. So it's the branch and bound tree, an iterative algorithm, and it finds good solutions along the way until it finds the optimal and proves it. That's when the solver stops usually. But you can stop it earlier. You can say that if I know that theoretically I am at most 5% away from the optimal, I will stop the solver because I really don't need that 5% improvement. So decreasing this value towards 0 might increase your solution time. Especially we will see it when we are solving a 3-period problem, since we have already lots of variables in our problem, and then it will keep increasing. The problem might get a little bit difficult to solve, but in this case our problem is like small enough, so I will just define a very small tolerance. You can also assign a maximum solution time. So when solving these problems, sometimes optimization takes a long time, maybe like 10 minutes, 20 minutes, whatever. So you can define a maximum time, and then the solver will stop and then will return you the best solution it has found so far. I usually leave this empty. I try to find the best solution I can find. I will just click OK. And when I click OK, see, it's already showing you, but yeah, it's solving the problem. I'm not sure if this problem solution has changed, but yeah. So that's something that you should be aware, that the default percentage gap, optimality gap, is 5%. So some of the things I mentioned here, like maybe, reducing the space, the solution space, and defining a higher percentage is what most of the tools are doing. They are shrinking the solution space so that the problem is solvable in size. They're also eliminating some of these players. I mean, you don't really need to have all these 600 players. Some of these players never play anyway, so you can remove those, or at least they do not appear in the optimal solution. So you can safely discard those and make the problem smaller. In this case though, we let the optimization choose whatever it wants. We gave all the players, and so this is technically the best you could do when you are solving a single period FPL problem. So you are including everything. You are including captaincy, squad limits, team limits, everything. So that's all for today, and the next time I will be talking about multi-period FPL problem. So on top of this, we will build a system where we will have multiple weeks, multiple week projections, and we will be talking about the optimal transfer policy, which players to buy and which players to sell. We will also feed your current squad as an initial input, so that the problem will take your current squad into consideration when suggesting which player to sell, buy, and at the end, that will be the ultimate tool that you could use. I mean, you can give your current squad, and then you can ask optimization to find me my optimal move, like which player should I buy, should I take a hit for my transfers or not. Hopefully I will be covering it in the next video, and thank you for listening to me.